Welcome back to our Python class, and we are doing some regression, a machine learning application, right, using well-known linear regression, using scikit library, and we just perform the simple fit and prediction pipeline on this diabetes dataset. Of course, just doing the steps, that's nice. It would be nice to interpret this data. Again, we have a predictive model, right? So given this data, we can make predictions. But the only thing you should notice, of course, if you remember, this is not or data, right? Which we fit on, which we predicted on the prediction on a test set, right? These values, what do they mean? This is there's 0, there's minus 0.10. Well, it certainly looks like this BMA data describes the diabetes dataset. So maybe we'll get we already have it, right? There is description. So I think it's called diabetes, right? Description, yes, indeed, right. So this is actually I'll rather print it, right? Because this is be nicer, right? Of course, right. It's diabetes dataset. It's based from I think 1970s, I believe. You check here, or Stanford, from 2004 actually. It's from 2004. I think it's also available at UCI. Also link to diabetes dataset, dataset on UCI. Right. So let's check. I think it's the same one. Is it there? Yeah, it is the same one. No, this has actually more attributes. This might be a different one. This has 20. This has insulin levels and others. This is actually a different one, right? But also, while I think it's the same dataset, it just has more features actually, right? Insulin dose, glucose, exercise activity, right? Meal ingestion. This actually is more different. This is different dataset. Okay, but yeah, right. So this is the one we use. So yeah, total serum cholesterol, lipoproteins, total cholesterol. Log of serum triglycerides level. Well, again, I'm no dietitian or a biomedical professional, but yes, so these are values. But of course, I would be very cautious. Possibly, right? There's no certainly level, right? So yeah, I think it might be same, possibly different. Possibly different. I'll say possibly different data set. I think it might be same, and actually, right? It just has more. This has more compressed data, but also. It's not mentioned. Yeah. So yeah, this is important point. You noticed how we did it. Let me describe this, right? So let's describe describe, right? These are age, sex, BMI, BPI. Let's do transcribe. Let's do transpose, right? I'll do transpose, right? So count, mean, max, right? So again, in what world is the average? Well, look at this average. Average is basically e to the minus 19, basically 0, because we remember floats are not very precise. 19 zeros after comma, right? Minimum is minus 10, maximum is 0.1. So again, same goes for sex actually, which is actually gender, right? But there are only two values. Again, why? What's going on here actually, right? Because we need the numerical model, so all these values have been converted to numerical. Again, it doesn't make much sense, of course, for a gender, sex to be, negative or positive, right? But this conversion is done to make this model usable with regression, right? So again, it's not always going to be, for example, this part here, right? This attribute, right? It's not really, you don't really use it. It's not, I would say, it's a little bit questionable because you have no order, right? It shouldn't really be an ordered attribute. Well, BMI, again, even scale, it should be pretty reasonable. But okay, so let's do age and BMI. Again, so these are scaled, right? Original values, you can find them in original dataset if you look around, but these have been this means so the values, so as the note says, the values have been normalized, right? Mean is 0, standard deviation is 1, or actually it looks like maybe not 1. Well, possibly maybe 0.1. Let's check. Scale by the standard deviation times the square root of n samples. So now sum of squares. Okay. Sum of squares of each column totals 1. So rule being sum of squares must be, so sum of squares on sum of squares in each column is 1. Okay, so pretty interesting, right? All right, but again, so this why is it done? So in this way, so again, we can do some correlations, of course, right? Oh, let's do some correlations, right? Progression, right? Let's sort values, right? So let's do that. Right. Okay. So what does this mean? How to interpret this data, right? So we have some strong correlations and some negative correlations. Well, actually, so BMI, the one we used, right, is strongly correlated to progression. Okay. So what does S3 means? Okay, that means it's negatively correlated, right? So the higher the S3, the less progression. So what's S3? S3, I think, was high density lipoproteins. I think those are the good ones, right? Yeah, I think they are the good ones. I hope, right? I don't. Again, maybe some of you dietitians will correct me on this one, right? So again, so now we have a better idea of data. Again, so the takeaway, the key takeaway from all of this is to know your data and what has been scaled. So questions to ask before you do any regressions, of course. To ask. So questions to ask. So questions to ask. So how to is. So questions to ask. So questions to ask before fitting a model. Right? Well, again, has data been clean? Again, has data been normalized? Right? That's an also question, right? So yeah, so we can see again. So positive, right? Positive values means negative. Yeah, okay, all right. So something around 0 means so gender is not correlated. Of course, again, well, it could be, right, in case, you know, but not in this case. So probably we don't need to use sex, but let's use so age also is very, so anything, so strength, so so anything over, fine, right, okay, I'll say that, okay. All right, so we'll use S5. So S5 is also strongly correlated, right? So this is probably log of serum triglycerides level. Let's use that as well. So let's use a fitting, knowing this knowledge, right? So let's use it. Let's use a fitting to let's fit. Well, we can do all, but let's not do it. That's too much. Let's fit BMI on S5, right? So. Right, to the array, right? We know in business, of course, right? So simple. Of course, we already had, of course, right? Split, right? We didn't have to do it again, but let's do it. You know, since right? Why not? Oh, sorry, we didn't need. Well, let's do it again. Right? Split. Yeah. All right. And again, this 42 is arbitrary. 42 is arbitrary, right? Just something that we get the same result each time, right? It's you know, it's just an answer to everything, right? All right, and now do we have the model? We already have the model, right? Let's make a new model. Create linear model, right? And we have time. Maybe we'll stop. No, let's do it. Instant model, right? I'll override the old one, unfit it, fit the data. Yep, extrain, same steps, right? Make some predictions. Right, and plot the results, right? And now we'll run it. 3D plot the results. 3D plot the results. Right, let's see, can we do this? I don't know if it's gonna work. Maybe not. Yeah, BMI is 3. Okay, looks okay. What do we do? Right. Y prediction. Let's see. Maybe it'll work. I don't know. But yeah, you can see the line, right? You can see this plane. Yeah, it worked right there. So the answer, right? You can see a nice plane. Well, maybe we need to play around with it, but yeah, you see the idea, right? It's a planar projection, basically, in three dimensions. All right, let's continue after the break in our live session.